Right, hey guys, Miss Smith here again. So we have covered vertex form, we've covered factored form of quadratics, and so the big one that we need you guys to leave here knowing and remembering for Algebra 2 next year is standard form. Okay, so this will help to kind of add on some of the Khan Academy stuff, or maybe if the Khan Academy guy starts to confuse you, hopefully this helps to give you an easier way to solve it. I'm going to show you how to use an online website to just get some answers, call it good, and then move on and focus on your performance assessment or your final exam, which is coming this week. No, it's not due this week, but it is coming. So we are almost done. End is near. Okay, so let's jump into the standard form. Okay, so standard form is written as ax squared plus bx plus c. A is the coefficient or the number squished with the x squared or the quadratic term. Okay, then b is the coefficient of the linear term, which is just the x by itself. And then c is your constant, which is the number that stands by itself with no variables. Okay, then we actually kind of learned about each of these forms, and we learned about some things we can find from each one before we even left for spring break. I know some of you might not remember it, but if you keep your notes, go look at them, okay? So we learned before, and we're reviewing it, that we can find our axis of symmetry using the formula x equals opposite of b over 2a, or the better way to write it would be opposite of b over 2a. I just couldn't figure out how to get my iPad to do that for me. So here we go. All right. So then once you have the axis of symmetry, you now have the x value of the vertex. Remember that vertex is that special point that we need to find in all of our quadratic functions. Okay, then we're going to substitute that x in. So we're going to plug it in. We're going to substitute that x in to find the y value. Then we'll graph that vertex. After we've graphed the vertex, then we can have a little XY table. So we'll have our vertex here, X1, Y1, and then we can pick some points around it, or we could pick a special point, like maybe our Y-intercept, because all Y-intercepts have a Y or an X of 0. So we go find the Y by plugging it in. Okay, so let's look at that by hand, but then I'm going to show you a super easy way to get past your homework this week. I bet some of you will appreciate this. If you just watch this video, then you're set, okay? All right, so let's look at it. All right, so we have y equals 4x squared plus 8x plus 7. So let's find our vertex first. Okay, so we have opposite of b over 2a. Opposite of b over 2a. So b is a positive 8. So the opposite of b is a negative 8 over a is positive 4. And so it's 2 times positive 4, and then I'm going to simplify that. Negative 8 over 2 times 4 is positive 8. Negative 8 divided by positive 8 is negative 1. So that is my x value of my vertex. Okay? So if I'm trying to find my vertex, I now have my x value. Now I need to go find my y. So I'm going to take that x and I'm going to plug it into everywhere I see an x. And remember, when we substitute things in, we have to slap down parentheses. Okay, so let's do that. So we're going to go 4. Whoop, I see an x. So slap down those parentheses and plug in a negative 1 squared. The parentheses are important with those negatives, especially if you don't put that negative 1 in a parenthesis and then you go put it in a calculator, you will get the wrong answer. Promise. Okay. All right, then plus 8, whoops, see an x. So slap down those parentheses, plug in a negative 1, plus 7. Okay, then you could solve it out by hand. I'm going to solve it out by hand because we're on this video. But from here, if you wanted to put that whole thing just like you see it in a calculator, you can. Okay, so we have, I'm going to drop down that 4, the negative 1 squared. So negative 1 times negative 1 is just positive 1, plus 8. So I'm going to do order of operations. I'm taking care of those exponents first. Now let's do our multiplication across, or multiplication or division, but in this case, we only have multiplication. So 4 times 1 is 4. 8 times negative 1, positive 8 times negative 1 is negative 8 plus 7. And then I'm going to combine those. 4 minus 8 is negative 4 plus 7. Negative 4 plus 7 is 3. Okay, so that means my vertex was at negative 1, 3. So once I have this, if I was looking at a graph, so on Khan Academy, you're gonna have to move some points around. You grab it, move it. Okay, so you're gonna go plot your first point at -1, 3. Okay, and then you can find some other points. So they're calling this a little axis here. Okay, so then we can go find some more points. So let's go create a little XY table. So I have my vertex, which is -1, 3. So you have two options here. You can go 1 to the left, 1 to the right, or like 1 to the left or 1 to the right. So meaning I have that X value of -1 right here. So then I could go either to 0 or I could go to -2. But my hint for you, for the sake of these Khan Academy assignments, none of their y-intercepts are crazy big. Just go to the y-intercept, okay? So let's go plug in 0 for x, because all y-intercepts have a 0 for x. So if I were to plug in a 0 into all of these x's, so I'm going to get 4 times 0 squared plus 8 times 0 plus 7. Huh. Well, 0 squared is just 0. And then 4 times 0 is 0, plus 8 times 0 is 0, plus 7. So that C value is actually our y-intercept. Anytime something's on standard form, it's super easy to find your y-intercept because you can automatically go find that C value. And then if you were to plug in zeros in these X spots, then those terms go away. Okay, so that means we found our y-intercept to be, so I'm gonna move that out of the way so we can graph. All right, so we found our y-intercept to be 0, 7. Okay, so then I would go up to my graph and I would, you on Khan Academy, you're gonna pull that second point up to 0, 7, so we can say it's like right there. Okay, and then Khan Academy will automatically graph it for you, but for us, we could know there's a corresponding point at -2, 7, because it was 1 to the left, 1 to the right, okay? That should look more like a U, remember at Soldier Boys math, but struggling on the iPad, okay? So that's what you can do. Now, if you wanna see how it might be easier, okay, so let's hop over to Desmos, and then I'm gonna show you how this might be easier for you to do. All right, so let's remember we are going to desmos.com. That's DESMOS.com. Okay, so then I'm gonna push start graphing. So remember, you could open up a tab with Khan Academy on one, and then you could open up Desmos on the other, but we're not gonna do that, we're gonna stay right here. Okay, so in this line right here, this is just like kind of like a y equals, like an f of x equals is one right here. It's like put a function here for me. It wants to graph it for you. So we're gonna plug that in, 4x squared, arrow down. And in case you're wondering how to make that x squared, it's shift 6. It's that little caret key, okay, the little up arrow. Okay, so 4x squared plus 8x plus 7. Ooh, look, I have a parabola. So let's check our answer. We were supposed to get a vertex we found at -1, 3, and then we found a y-intercept of 0, 8. So let's go look. So if you click on it, it's gonna pop up, oh, -1, 3, 0, 7. If I just said 8, I'm sorry. 0, 7, okay, so we found that vertex, we found the y-intercept. So if you were on Khan Academy, that's where you bounce right on over in your Khan Academy, and you would go and drag that vertex to the -1, 3, and then you would drag that other point to 0, 7, and you're done. Okay, let's try another one on Khan Academy. Okay, so now we have example 2. This one, man, those fractions, still can't figure them out, but it should be written like this. That's the better way. Okay, but either way, same thing. Okay, so this is our function. Okay, we could technically go do the opposite of B over to A and find the vertex and all that, but honestly, that A is kind of messy. Okay, so instead of having to worry about that right now, especially when you guys don't have calculators to help you out, we're okay with you hopping on over to Khan Academy, find the vertex, find the y-intercept, and call it good. Now I want you guys to think for a second before I click off the screen. We talked about how standard form makes it easy to find our y-intercept. So I want you to think for a second, what do you think the y-intercept is? And when we go to Desmos, you can check yourself. Think about it. Y-intercepts all have an x of 0. So if we plugged in 0 for those x's, what would be left? Okay, let's click over. All right, so here we are. Okay, so let's go ahead and delete this. I'm going to type in -1/a, arrow back up, x squared plus x minus 4. Ooh, minus 4. Okay, so we have a parabola now, and we can see our vertex or our maximum because this time it opened down because a was negative. Okay, so I see it 4, -2. So that's where you flip on over to Khan Academy, go and drag that vertex to 4, -2. Okay, and because you need a second point to graph a parabola, you can look at this y-intercept, which is 0, -4. Hopefully you guys caught that it was -4 because it's that c value right there, a -4, because this x would go away because it's 0, this x would go away because it's 0, so all that's left would be the c value, -4. Okay, so those would be the 2 points. You graph it, you push check, you're done. Okay, that's the first section this week. Okay, that's standard form. Opposite of b over 2a helps you get it if you're doing it by hand, and you'll get more practice on that next year. But right now we just want you guys to be introduced, to know what a parabola looks like, okay, and to kind of start working with some of these systems, okay? So let's flip back over and let's look at those dreaded word problems, okay? All right, next, the dreaded word problems, right? Okay, but you got this, okay? I'm gonna give you easy tools to get these right. Okay, and here's the thing, is a lot of things in life have to do with quadratics. So if you haven't caught one of my past videos and you didn't pay attention to them, when you throw a football, that's in the shape of the U as it leaves the quarterback's hand, hits the receiver's hands. That's a quadratic function, okay? When you throw a basketball, okay? There's a bunch of other things that you do that are in quadratic functions. So you see these every day in life, but you don't realize that you can even measure them, okay? So let's think about the special things that we have going on in this, how we can find it, and then I'm gonna show you a shortcut to make it easy, okay? So we have a lane throws a stone off a bridge into a river below. The stone's height in meters above the water, x seconds after a lane through it, is modeled by, so is that equal? So that just means that h of x is our height. Okay, so our height is modeled by -5x squared plus 10x plus 15. So that's a quadratic function because our highest exponent is a 2. Okay, so we have x is seconds. Okay, those are things that we need to know. Now it says, what is the height? So what is our height with the of the stone at the time that's supposed to be it, at the time it is thrown. So let's put ourselves in this situation, okay? We're throwing a stone off the bridge, and you're not gonna start your time way back here as you pull on your pullback of your swing. You're gonna start your time as it hits your hand. So if you think about it, you probably did stuff like this when you were a kid, like when you threw something, you're like, oh, how long will it take to hit the ground? You're like 1 million, 2 1 million, okay? That's what you did, that you technically were doing quadratic function math. You just didn't know how to model it or how to find specific things. So that's what we're doing now, okay? So the time that it is thrown is the time it hits her hand. So hopefully you can register that the time that it is thrown would mean that our seconds, our x, is 0. We just now let go of the stone. So we want to know what's the height when x is 0. So you could do this by hand, and you could plug in everywhere that you see is an x, you could plug in a 0. Pretty easy to get this one this way. But if you also think, because that c value, we just reviewed that. But if you also think about it, x of 0, that means our initial value. So the initial value when that stone is launched out of my hand, that initial value, which is what we call our y-intercept. When x is 0, we're looking for our y-intercept. So let's think about that when we flip over to Desmos. Let's think about that y-intercept and let's see if we got it right. Okay, so height of the stone at the time it is thrown. The time it is thrown, x is 0. So that's our initial height, our initial value. So that is our y-intercept. Okay, second question. It says how many seconds? So that means we're looking for x this time. After being thrown, will the stone hit the water? Well, what would be the height when it hits the water? It just smack hits the water. Well, that's what you were measuring, is how long will it take to hit the water. So the height when it hits the water is gonna be 0. So now I wanna know when is h 0, and in this case, h is in our y spot, because that h of x right here, that is in our y spot. So I wanna know when y is 0. Well, when is y 0? Y is always 0 when we're looking at our x-intercepts. So you could plug in 0 if you wanted to. You could plug in 0 and then you could factor it and you could find your x-intercept. And remember, it's seconds. So if there's a negative one, we can't have negative time. Can't have negative time. So throw out any negative answers when you're talking about time. Okay, we're not time travelers. But you could do this and then you could factor it. So then I take out a -5, get x squared, and then that would be -2x minus 3 is left on the inside. Open up my 2 parentheses. So you could do that whole method and then do your little x method or your shortcut, but you don't even have to, okay? Let's flip over to Desmos and let's see how this will help. If you simply know, at the time it is thrown, x is 0, so that's my y-intercept. And then the second one, what's the x when it hits the water? So that means my height is 0. So that means my y is 0, which are my x-intercepts. Okay, so let's flip over to Desmos and look at our x and y-intercepts. Here we are with our Desmos. Let's plug this in. We're just going to go -5x squared plus 10x plus 15. Okay, and so now I'm going to look at this. I want to know, remember, I want to know my y-intercept first because I want to know what's the height when it's thrown. What's my initial value? So you can grab it and move it around until you see that y-intercept. So click on it. Oh, there it is, 15. So then you type 15. Okay, so our y-intercept, our height, our initial value was 15. Okay, then the second question says, what is the time? Well, how many seconds have gone by when it hits the water? So this would have been, it was in the air, it was in the air, it was in the air. And then this height right here, our height would be 0 when it hits the water. So let's see what that value is. It is a 3. Our x value is 3, so it would have been 3 seconds. Okay, so on the word problems, if you can simply figure out, is it asking me for the x-intercept, for the y-intercept, for the maximum, for the minimum? Okay, if you can figure those things out, Desmos, stick it in there, put your values in Khan Academy, and you are done. Okay, let's look at one more word problem. All right, so here we are. Marquise has 200 meters of fencing to build a rectangular garden. The garden's area in square meters as a function of the garden's width W in meters is modeled by, so remember that means that A is our area and the W is our width. Okay, so this is modeled by A of W equals -W squared plus 100W. What side width, so we're looking for W, will produce what side width will produce the maximum garden area. So remember, the maximum garden area is where is our y value? Because that A is in the y value. It's where is that y value at the very, so where is it hitting at maximum point? And then it says what side width. So I'm looking actually at the W. So what is the x value of the vertex, because that's our maximum or minimum, or just go look on your graph at your maximum and then go down, 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 down. What's my x value? Ding, ding, ding. Okay, so let's flip on over to Khan Academy and watch how easy this is, okay? All right, so here we are. The big thing with these is just making sure that you know what your problem is asking you to find, okay? So we had negative, instead of w, let's go ahead and just write x squared. So just change those other letters when you put it in Desmos to x's, it'll be easier. All right, so here we are. Whoa, that looks like a line. I can't see what's going on. So let's zoom. Whoa, that's so big. All right, let's keep going. Find the end of it. And I'm gonna click, and what's the vertex? 50, 2,500. Okay, so that's my vertex. Remember, it said, what is the width? What side width will produce the maximum? So it said, if it said, what's the maximum area? It would be that y value, that 2,500. But it says what width, and we know that width was in the x spot. So that means the answer would have been 50, okay? So that is that. That is standard form and using Desmos to help you get there. Hopefully that helps you guys. Next project's coming soon. Buckle down. Let's get this done. End is near. Bye.